We're going to be showing you a dynamic graphics system put together by Rick Becker, Bill Cleveland, and Jerry Weil. The system runs on an Iris graphics workstation. Let's just, in the beginning, run over some of the salient features in the system. One major feature is point cloud rotation, and you can see a point cloud being moved about on the screen through the movement of a mouse, which is in the right-hand side of the screen, being controlled by a statistician's hand. Here's a scatterplot matrix. Carrying out operations on a scatterplot matrix is another of the important features in this dynamic graphics system, and as you'll see, this is a powerful tool for data analysis. The way we select different features, such as popping back and forth between point cloud rotation and brushing the scatterplot matrix, is through some pull-down menus that are at the top of the screen. Here's a pull-down menu where you can select operations, various features of the rotation operation. Here's some features that control scaling of the variables. We can also manipulate labels that happen to be associated with data. In this particular case, the measurements are on states of the United States, so every measurement has a label, namely the state, and we can manipulate it by that scrolling menu on the right of the screen. We can also use different colors in this system, which are selected by moving a cursor and clicking a button on the color that you want. That color on the right there is actually invisible ink, as you'll see a little later. The first example we're going to show you is measurements of 4 variables for 50 states of the United States: income, illiteracy, life expectancy, and high school graduates. Here we are with a brush moving around on the screen, which is being moved by a mouse. The brush is a rectangle. Points inside of the brush now are highlighted on all panels of the scatterplot matrix. Here we're now doing the highlighting in a yellow color. At this point, the brushing mode is transient, in the sense that points that are highlighted are no longer highlighted once they're no longer covered by the brush. Now we've just popped into a lasting mode where when we do the highlighting remains. As you can see, we sweep across, and points that were previously highlighted remain highlighted. Now we've just popped into an erasure or a removal mode in which you're able to remove the lasting highlighting which is on the screen. Now what we've gone up and grabbed another color from that palette at the top of the screen, and now we're coloring points in a lasting way with red. So all the points have been colored either red or yellow. Now we're removing the red coloring of the points by the removal operation. If we want to get rid of points, we come over and color them with invisible ink. Which actually is happening is that we're coloring them in the background color of the screen. And so you can make points go away so that you can focus on other points. You can change the size of the brush. This is extremely important for the variety of applications to which brushing is put, to be able to get brushes of different shapes and sizes. Here now we've made a brush which is smaller than before. In fact, we've done this in order to carry out another brushing operation, which is identify. Now when points fall inside the brush, the labels for the points come up onto the screen. Like here's Alaska, and notice that Alaska is shown on all panels of the scatterplot matrix. There's Nevada. And now we've done it in a lasting way, keeping the labels up, so Alaska and Nevada are there together, and now we've just removed them by the removal operation. We can also select states by going over to the scrolling menu on the right of the screen and just move through them. And in this particular case, since we're in identify mode, what happens is when we say cover Alaska, the label Alaska appears by all points on the screen. The states of the United States can be broken up into different regions of the country, which is a categorical variable. As you see, there are 4 regions: north, central, northeast, south, and west. We've picked the highlight operation. Now when we cover the label for a region, all points within that region are highlighted on the scatterplot matrix. As you can see, we're doing this at first in a transient way, and then at the last operation we did it in a lasting way so that all the north-central points remain colored on the screen. And now what we're doing is we're going through the points in order, coloring them in a lasting way with different colors. And there we are coloring in the south with a color that I can't recognize because the monitor I'm looking at is so lousy. We just did the south again for some reason. Now finally the west. So all points have been colored by a different color according to what section of the country we're in. Now we go back with a removal operation and get rid of all the colors. It's possible to blow up one panel and make it fill the whole screen for detailed looking. When we do that, we can carry out any of the brushing operations that we did before, except of course there's just this one panel. And now we can pop back to the full scatter plot matrix. Any operation that we carried out on the blown up panel remains when we go back to the original scatter plot matrix. Let's take a look at point cloud rotation. There's a variety of ways that rotation can be controlled. One is just to rotate about some axis. We can rotate about screen axes or about data axes. In this particular case, we're rotating about a vertical screen axis. Now we're rotating about an axis which is perpendicular to the screen. This is a way of moving around the point cloud that affords very delicate control. As you move the mouse in a particular direction, it's as if you reached out and grabbed the box and pushed it over and turned it in that particular direction. We can do brushing operations, as we did on the scatter plot matrix when we've got a point cloud on the screen, by using a brush. Here now we're using the brush to get rid of the labels that were brought up in a lasting way earlier when we were operating on the scatter plot matrix. Here now is a set of measurements of velocities of a galaxy. The vertical axis is the velocity, and the floor of the box is position on the celestial sphere. So this is a 3-variable example. Notice that the velocity measurements look like a dragon, a flying dragon, in fact, with all sorts of appendages. That's really not too informative. The important thing is that it's clear that this is a surface with noise superimposed on it. What we're doing now is coloring in particular subsets of points that are defined by the way the measurements were made. Notice that what we're doing is coloring in yellow a collection of points. Well, now we're moving somewhere else. We're moving through these appendages in the dragon. But right there, that's a set of points running up the spine of the dragon. Now we'll rotate it so we can look at the dragon with its spine highlighted. This actually corresponds to one collection of measurements that were made all at once on these galaxy velocities. Now we're highlighting in red other collections of measurements that were made simultaneously by slit spectroscopy. So now we've got 2 different collections of measurements highlighted along different slits, and rotating and getting a sense of the structure. And now what we're going to do is show off. The reason why we picked an iris is that it's a particularly powerful graphics workstation. And in fact, we can rotate this point cloud well beyond the point where the human brain can appreciate what's going on. With that, it's time to quit.